Today I want to briefly talk about Simpson's Paradox. Simpson's Paradox is a phenomenon in probability and statistics in which a trend appears in several different groups of data, but disappears or completely reverses when these groups are combined. A typical example is shown here where you have 5 different clusters of data clearly identifiable visually. For example, this is one cluster right here, etc. You can clearly see these clusters. And in each cluster, the data exhibits a positive correlation, meaning that when X increases, Y also tend to increase. However, if you look at the data set as a whole, it has a negative correlation by looking at the whole data set. So what's going on? Well, that is Simpson's paradox. And you can find this in other areas too. For example, in sports statistics, you can have something, for example, like batting average in baseball. You could have a batter that has the best batting average in one season. It has the best batting average the next season. But when you combine the 2 seasons and look at the total, he doesn't have the best batting average. Same thing happens with pitching earned run average. You can have a pitcher that leads the league in ERA for 2 years straight, but when you combine the 2 years, his ERA may not be the best. Same thing you can think about in basketball and other sports that rely on performance averaging. So the question is, does Simpson paradox appear in structures? And the answer is yes. And I'm going to show you a very simple example that yields very unintuitive results. Consider here what I call case A. So I'm going to draw a line here, and you're going to look above that line. There are 2 springs. One shows a lower displacement, the other one the higher displacement. In one case we have stiffness of 3, force of 1, the displacement is 1/3. In the other case we have stiffness of 11 and force of 4, and that leads to a displacement of 4/11. So the lowercase delta 1 is smaller than capital delta 1. We can similarly construct another case that I'm going to call case B, in which we come up with another set of springs that have the same behavior, right? The same trend. K of 10, P of 9 gives you a lowercase delta 2 of 9/10. K of 1, P of 1 give you an uppercase delta 2 of 1. Again here, capital delta 2 greater than lowercase delta 2. But now we combine these 2 cases and the opposite happens. So we take these 2 springs right here and combine them and apply the combined force, and we get a total spring of 13, right, by placing them in parallel, and a total force of 10. That yields a displacement of 10/13. If we do the same thing with these 2 springs that exhibited the higher displacement, now we get a stiffness of 12, a force of 5, and a displacement of 5/12, which is smaller than the displacement of lowercase delta. So that is, by combining 2 cases that individually resulted in the smallest displacement, we have now obtained a larger displacement. than the two cases that individually showed the largest displacement, but when combined show a smaller relative displacement. So this is clearly a case of Simpsons paradox, where combining two things that exhibit a certain trend individually results in the reversed trend. There is no magic here, obviously, it's just arithmetic, but it does show that you have to be a little bit careful when you're analyzing structural systems and when you're designing structural system by combining things that have a certain behavior. Their combined behavior may be opposite than the individual behaviors that you're combining. So watch out.